Friends, welcome to my channel. Dhanesh here. In this video, I am going to discuss about quantum cryptography. Before getting into quantum cryptography, let me discuss what is cryptology or cryptography. Cryptology is the practice and study of techniques for secure communication in the presence of third parties called adversaries. More generally, cryptography is about constructing and analyzing protocols that prevent third parties or the public from reading private messages. Various aspects in information security such as data confidentiality, data integrity, authentication, and non-repudiation are central to modern cryptography. Cryptography exists at the intersection of the disciplines of mathematics, computer science, electrical engineering, communication science, and physics. Applications of cryptography includes electronic commerce, chip-based payment cards, digital currencies, computer passwords, and military communications. Cryptography is the science of exploiting quantum mechanical properties to perform cryptographic tasks. The best known example of quantum cryptography is the quantum key distribution, which offers an information theoretically secure solution to the key exchange problem. Key exchange is a method in cryptography by which cryptographic keys are exchanged between two parties, allowing use of a cryptographic algorithm. The key exchange problem describes ways to exchange whatever keys or other information are needed for establishing a secure communication channel so that no one else can obtain a copy. The public key can be sent over non-secure channels or shared in public. The private key is only available to its owner. The advantage of quantum cryptography lies in the fact that it allows the completion of various cryptographic tasks that are proven to be impossible using classical communication. For example, it is impossible to copy data encoded in a quantum state. If one attempts to read the encoded data, the quantum state will be changed. We call it as no cloning theorem. This could be used to detect eavesdropping in quantum key distribution. Versus conventional cryptography. In classical cryptography, the original text is transformed into ciphertext, which is then transmitted across a channel controlled by a data string called a key. The receiver will be able to get the original information and decipher to the original text only if he is in possession of this key. Classical cryptography comes with two main techniques, symmetric and asymmetric cryptography. However, these cryptography techniques face a threat from quantum algorithms. For example, the famous Shor algorithm is capable of breaking an asymmetric cryptography techniques such as RSA and elliptic curve. Another quantum algorithm known as the Grover algorithm is capable of attacking symmetric cryptography. Quantum cryptography, on the other hand, offers safe key exchanges based on the principle of quantum mechanics. The security of conventional cryptography is threatened by weak random key generators, advances in CPU power, new attack mechanisms, and the development of quantum computers. With regard to quantum computer in particular, such encryption is rendered useless. The data encrypted today can be intercepted and stored for decryption by quantum computers in the future. Here's about the applications of quantum cryptography. Quantum cryptography is a general subject that covers a broad range of cryptographic practices and protocols. Some of the most notable application of protocols are going to discuss here. First is quantum key distribution. Next is quantum coin flipping, quantum commitment, mistrustful quantum cryptography, bounded and noisy quantum storage model, position-based quantum cryptography, device-independent quantum cryptography. These are all the applications of quantum cryptography. First, we will known and developed application of quantum cryptography is quantum key distribution (QKD), which is the process of using quantum communication to establish a shared key between two parties, Alice and Bob, for example, without a third party, let's say Eve, learning anything about the key. Even if Eve can eavesdrop on all communication between Alice and Bob, Eve tries to learn information about the key being established. Discrepancies will arise, causing Alice and Bob to notice. Once the key is established, it is then typically used for encrypted communication using classical techniques. For instance, the exchanged key could be used for symmetric cryptography. Thanks for watching. Please like, share and subscribe. Thanks a lot.